Yeah, this is kind of nerve-wracking because Women Who Go is really small and very friendly, and there's more of you, so I'm a little bit nervous. Okay.
They're all friendly. They don't bite.
Okay. Okay. Great. All right. So my talk is called Callstacks to Giverny, Go Graphics CLI. And it's about a little project I did just to present at Women Who Go. Okay, so my name is Julie Kohler. I am relatively new to Go. I've never written it professionally. I've always worked in other languages. This is kind of a little work history from me. About 4 years ago, I started working as a software developer at inContact. I was mainly a front-end developer for them. And then I moved to Health Catalyst for a little bit, and then went back to inContact. Right now I work at Claravine, which is a marketing technology startup that was based in Provo, now we're based in Lehigh. But I just accepted a job at a company called Splice that works on music production technology. And they use a bunch of Go on their back end. So that's really exciting for me. I'll be starting with them in mid-November. Okay. As Mariah mentioned, I gave this talk back a few months ago at Women Who Go. This is Mariah's little avatar from the Women Who Go Slack, and I think it's super cute. And like she mentioned, she invited me to present. I wasn't intending to submit an abstract to the conference because I thought people were paying for this and they would probably want to listen to people with lots of experience. But Mariah encouraged me to apply, which I really appreciate. And so as she mentioned, the Women Who Go and the Go user group meetups are combined, and they're really great, and I would encourage you to check them out. And just so you know, all attendees are welcome, regardless of gender, at the Women Who Go meetups. In fact, it's usually mostly men, I think. It's just the ratio in the field. Okay. So while I am new to Go, I have done a little bit of graphics programming in the past. The very first, one of the very first things I ever coded was a little Mario thing done with jQuery, where you can move Mario around, and you can make him jump, and you can make him grow and shrink. It's really fun, and it's pretty simple. And what I thought was cool, so the tutorial that I followed to make it just had you do a little sprite, right? But then I added the pipe background to it, and I thought it was so cool how suddenly it felt, instead of just moving something across the screen, it was like Mario was having an adventure. And I thought it was really awesome how graphics could make the difference in an experience, and kind of make it a more immersive or engaging thing. I also, at one point, coded this. This is another just small side project, but Romek Marber was a book designer, or a designer from Penguin Book back in the 1960s, and he came up with a design for how to lay out their book covers that was based on the golden mean. And so I kind of created an emulation of this, sort of, so we can say, like, Go West Conf. It's the title of our talk, and we can change this. Let's do the chemical diagram, and ta-da, Anyway, so it's just a fun little thing. And at my job at inContact, they make software for call centers, and it was natural language processing software. When they say this call may be recorded for quality assurance, sometimes it is recorded, and sometimes it's pumped through natural language processing software, and then somebody makes a widget out of the results, and I help make those widgets. So they measured things like silence on a call or the sentiment of the customers. The weirdest thing I worked on was a frustration widget. I didn't think it should be that hard to tell why your customers were mad, but people paid us a lot of money to tell them why and represent it in pretty bar graphs. Okay. Anyway, so when I was thinking about what kind of side projects I could undertake, with Go, I knew I wanted to do something with graphics. And one of the best ways to work with graphics in a programmatic way is to use SVGs. SVG stands for Scalable Vector Graphic, and SVGs are actually a dialect of XML, which I didn't know before I did this project. Actually, I guess it should have been obvious because they're just tags, you know. So they are. It came around in 1999, so it is younger than I thought it was also. And the word vector here indicates that the image is described in terms of a Cartesian plane, which brings us a number of benefits because the plane can be larger or smaller, but the relationships between the points don't change, allowing us to have sharpness at different sizes. And it's not like a raster graphic, which is made up of a series of squares that are kind of filled with colors, which when you resize them can lead to blockiness. So some of the pros of using SVGs in our work, like I mentioned, it's scalable. Also, it's in the name that it's scalable, so we don't lose quality when they're resized. They're dynamic and programmable. They have all of these, they take in all kinds of values, and you can take data and put them into these graphics and then represent it in this human readable way. It's such a cliche to say a picture is worth 1,000 words, but people really do grasp things more quickly if you can show them shapes and colors. And SVGs are awesome for that. And then also, they take up less memory than other graphics because you're not mapping a huge chunk of memory to a display and then figuring that out. You're just describing mathematical relationships. However, there are challenges in using SVGs as well. The spec is huge. I'm gonna take a second here, and we're just gonna scroll through all the things that are in the SVG spec. It just keeps going. So yeah, it's massive. And so there can be a big learning curve associated with it. And many elements have many different properties on them, right? That can make them behave completely differently from a visual perspective. So it's not necessarily that these properties are causing tiny tweaks. Sometimes it can be like night and day differences in what you get in your graphics, right? So that can be difficult. I feel like even people who are experts in SVGs are still learning all the time how to cause different visual effects just by combining them differently or providing different values into them and that type of thing. They can be kind of finicky. It can feel easy to break your image. Like you can get this sense of like, oh, I've adjusted this value and it looks better. And if a little change is good, a lot of change must be even better, right? And that sometimes just turns out to not be the case. Sometimes you'll get something that just doesn't even render anymore. And the interactions between the element types are not always easy to predict. Some elements also take in matrices of like 20 values, and each of those little values in that matrix does a different thing to the image, right? So there's all these complications with using them. And also, it's a different kind of coding than you might be used to. There aren't error messages unless it is truly broken syntax, like you have an opening tag and no closing tag. And you can change a value in such a way that it will make it impossible for your graphic to render the way you want it to, but there's nothing that clearly tells you why anymore, right? Like you change something and now it's gone or whatever. And so it's just not the same. But on the flip side, or on the positive side, like once you kind of get a handle on them, you can use them to build all these awesome things, like represent graphical relationships, as in graph relationships, right? Nodes and edges, and also all kinds of things like maps, but fill them with data. And so all these kind of infographic type applications to them are super cool. Okay, and then these are just some of the SVG elements that are supported by Go. You'll notice there's shapes, lines, text, paths, which are connecting pieces, right? Sometimes if you need to draw a really complicated shape, you won't use one of the shape elements, you'll just use a path to draw it out. You can have images inside the SVGs. We'll see a bunch of that in the demo. There are also gradients. There are transforms that change how things look. Animations, which you can do the coolest stuff with the animations. A ton of filter effects. And then a bunch of metadata elements that kind of affect either grouping or labeling and that type of thing. Okay. So, like I said, when I was thinking about my next project, I knew I wanted to do something with graphics, and then I was thinking about what I could do that would involve Go and graphics, and then I found this Go graphics library that did like pretty much everything I had wanted to do. And I was like, that's awesome. I'll just write a CLI on top of it, right? Use it. And because everybody uses Go to make CLIs anyway, and I want to know what's up with that. And so that's what I decided to do. And I made some pretty things, and I made some chaos, and you're seeing both of that, and we'll explore how in a bit here. So the library that I discovered to use to do this is Anthony Stark's or AJ Stark's SVGo library. I'm saying it SVGo. I don't know how it's actually pronounced. If he's listening, please add that to the README. Maybe I'll make a issue request or something. But it has a ton of cool features. You can, render things like on the web and then interact with what you've rendered. There's a ton of demos in there that you can play with. And it's not quite as dynamic as editing the SVG elements. Not everything in the spec is in the library, and there are other limitations, like a lot of times SVG elements will take as values for their properties either percentages or like floats and things. And a lot of times this library only takes floats. You can't pass it a percentage. So there's limitations. But it's still super cool, and you can do a lot with it. If you're not interested in using a library, you can just use the standard XML package to write SVG stuff. So we're gonna take a quick look. I don't want to spend too much time demoing someone else's thing, but it's just so cool. So this, for example, let's make some flowers happen, okay? Let's see, how many flowers do you guys want to grow? 50, okay, sounds good. Yeah.
We're gonna start.
Let's start with 50, and then let's see, flower.go, and what's our other thing? Yeah, you said we should scale them, you're right, for S, our size, because these are fewer flowers, so we're gonna make them big. So let's say 500. Oh, I can try. Hang on. Okay, so what should have just happened is that we, this was writing standard out, and we just piped it into this flower SVG file. And if we go back to my browser, whoa, there's our flowers. They don't really look very flowery anymore. Maybe we should scale those back down. Yeah, we've made fireworks now. Anyway, so you can change the values like that. The other one I think is super cool. He has one that does planets, the relative sizes of the planets and their distances in the solar system. And so like, it's just so cool. Those are all dynamic values that you're assigning just with little images of the planets, right? So I think that's fun. The author of the library has also talks and stuff where he shows like all these dynamic things with like charting the stock market and other things that you can do with it. Okay, so when I started thinking about I think I'm going to move into the technical part of how it works in a second, because it'll dovetail nicely with getting into my code. So when I started thinking about images dynamically changing, I thought of Claude Monet. He was a French Impressionist painter, active in the late 19th and early 20th century. And he was very interested in painting the same subject under different lighting conditions at different seasons to show how color constantly changes according to the sun's position. So he would go outside with a bunch of canvases under his arm, and then he would paint one until the light changed. Then he would set that one aside and then paint on the next one, and so on and so forth, just like all day long. And he built up these various series of the same subjects, just under different atmospheric and light conditions. And I think his paintings of the Rouen Cathedral, which you see here on the right, are so cool because it's almost like the cathedral is a surface for light, right? Rather than I'm here to paint a church. It's like I'm here to paint the effects of light on a surface. And it's just a very different way of looking at the world. I think Cézanne said something like, Monet was only an eye, but what an eye, because he was so concerned with these visual effects. Okay, let's see. Oh, and the series with these haystacks is called Stacks at Giverny, which is where Callstacks at Giverny comes from. It's kind of corny, but that's the origin. Okay, so a little introduction into, so basically what I decided to do was focus specifically on filters, because there's so much that you can do with this spec that I was just going to try to do things with filters. And so let's take a quick look at how Stark's SVG library works. It's mostly a lot of different functions that take this struct that represents an SVG. You need a writer so that you have someplace to write out your output. And then after you initialize this with your width and your height and possibly other values like a view box or things like that, then you're just calling other methods, and it's just printing out. You'll see it's just printf. This SVG filter element, or in this case, it can be anything, but for my use, it was mostly filter elements. And then just the values that have been passed in, right? And then you just close off the thing with an ending SVG tag, and then you have your SVG. So we'll look at what that, how that went for me. Okay. So please be nice as you look at this. One of the things that's still hard for me is deciding how to kind of organize and structure things in Go. I keep being like, and then I will make a class, and then I will put the methods in the class. No. Okay, and so it's a little bit of a change mentally. Anyway, so we have this main function, and I was influenced here by a blog post by Carl M. Johnson called Writing Go CLIs with Just Enough Architecture, that says basically magic is bad, global state is magic, don't have package level variables or a func init. And so it's like, okay, that seems, yeah, totally reasonable. I can get away with that. Anyway, so he recommends having the CLI and then creating an app using the values from the command line that are separate, and then they just stay on the app, if that makes sense. Okay, so we're going to do that. And so we have this app, and for filters, we're going to init these filters. We do have initialization there. And I decided to have those in a map that has their names as strings, and then they are all functions, okay? And their functions I've created here. And they're going to call functions from the SVG library also, but specific ones. Okay. So, and then the config, sorry, we should take a second to look at what app has here. These fields, it has these filters. Filter func just takes in this SVG and returns nothing. Then we have our app config, and then I associated canvas with the app. And then, so you create the app, and then you get the config, reading in from the command line. And then you validate the inputs, and so you're in and you're out, and filters I made as a special type. It's a custom flag variable. Maybe that was worthwhile. And then we parse it, and then we go along, and once we have the filters that our user wants to apply, we start applying them. And we'll go into more in how we like kind of structure them or stack them in a minute. But let's actually let's take a look at that now. So we create our SVG with SVG new. We start our canvas with our width and our height, like we saw in on the slide. Start the def tags, which is where you're going to put your filters. We create all our filters with apply filters. And so there's some things that so first we look through, and for all the selected filters we go, their names are the same as their function names. So we just call those functions with that canvas. And then at the end, we go through this process of adding an FE merge, because one of the trickiest things for me as I did this project was getting the SVG elements to like play nicely with each other, like adding them and then making sure they all showed up at the end. And one of the ways to do that is with FE merge. And there are other choices like FE composite and FE blend, but FE merge is the simplest one. It takes one in-channel instead of, or each of the nodes. So you have FE merge has a bunch of FE merge node children, and they all take one in-channel, which I can just use the names of the filters for that as well. And so then I don't have to like keep track of those result strings. It's just their names. And then we end it, and then it opens up in a browser. After we add our image, which is the in specified by our user. Okay. Okay, I think we should start trying it out because that'll be more fun. Okay, so looking at this list of filters and looking over here at this list of images, does anybody want to shout out a filter? Good choice. That one requires audience participation, so I'm glad you chose that one. And take a look over at the images over here. Do any of them call out to you? Tiger, good choice. Okay. I can't do this with one hand. I'm going to put this mic down. Okay, here we go. I can't type well, but I can type better than that. Okay. Tiger.jpg, or no, it's a PNG. Okay. Okay. What is your favorite color? Okay. Now I have yellow filter. Oh, Carlton is a great filter. Okay, let's put him in Tokyo. I think that's nice for him. Okay, Tokyo, and oh, we can do it both ways.
Oh, I want to see it both ways.
Okay.
Yeah.
Okay. And we'll name it C for Carlton. Hey! Just having a good time.
Yeah, what is Tokyo doing?
Oh, wow. I that might not turn out to be anything, but we can try it. Let's try it. Okay, so we have Carlton.gif, right? And then we have, oh, let's see. we would have to specify a filter for him. But what we can do is take Carlton and then do something weird like hue rotate. Doesn't sound interesting. It turns out really cool. It's just green because it was red. So now it's green. That's hue rotate for you. Oh, shoot. I haven't even tried that. This is a good question. Carltonception. It's just on top of itself. It's not that cool. Oh, yeah. It does kind of glitch a little bit, huh?
Yeah.
Okay. So I'm going to show you one sequence that I think is kind of cool. Let's use the haystacks as our in. And we'll do age for hay. And we can apply multiple filters. So I'm going to do dawn, day, and dusk and hope that works. Yep, and they're animated. So now it's nighttime. So yeah, with the animations, you can make really expressive, really dynamic things. It's a lot of fun. Anyway, how much time do I have? Okay, I'm coming up on time. I'll leave a few minutes for questions. Oh, let's do one more. Is there a last one you want to see?
We desaturate it down.
Yeah, let's do that. It probably will. Desaturate. Oh, yeah, he's cute black and white dog. Let's see what it originally looked like. He was colorful. Now he's less colorful. Anyway, so it was a really fun project to make. Bent my brain a bunch of times. Man, SVGs are tricky. Go is tricky, but together they're super cool. So thanks for the opportunity to talk about this.